In this video, let us discuss the ill conditioning and well conditioning system of equation. Let Ax equal to b is the system of equation where A is the coefficient matrix, x is the solution vector and b is the right vector representing right hand side of the equation. Now, in this equation you get the solution vector x by solving these equations by any method. We have already discussed the different methods here. Now, if for some reason the elements of A or B are perturbed slightly, that means there is a small change in elements of A and B, and that can happen during the round of error or numerical computation and or data handling that may occur. So, in that case then the solution will be different. If the slight changes of A or slight changes of B gives rise to the changes of the solution to a large extent, that means the small changes of A and B give rise to the large changes in the solution vector x, then this system of equation will be said as ill-conditioned system of equation. And alternatively, if small changes in A or B gives rise to a small changes in x, then that means the solution will be close to each other, close to the original solution, then this system of equation is said to be well-conditioned system of equation. Okay. Now, I am going to give you an example. This example is given x plus twice y equal to 4, twice x plus 3.999 y equal to 7.999, and in matrix format, if I say this is your A, x, y solution vector and this is your B. And if I solve this equation, then you get the solution like x, y, x value equal to 2, y value equal to 1. Now, give a small perturbation in A, let A dash is the new A, and we are giving, if you see the value of A dash is 1.001, 2.001, 2.001, 3.998. So, we have given very small changes in your A becomes A dash like this. Okay. Now, what will be this? So, the new equation will be your A dash, A will be A dash, x factor then B. And the solution of this, if we solve this equation, we get the solution as 2.9, x value is 2.999, y value equal to 0.001388. So, in this equation if I say, then this is your, this is a very large change while giving a small change in A value. Similarly, if we give the B vector, the change in the B vector keeping A intact, originally it was 4 and 7.999, now we have given 4.001 and 7.998. And the solution becomes xy equal to minus 3.999 and 4.0. So, if you see that, if you compare with the original solution, this is a very huge solution and that change is very large. So, we can say that this system of equation, this simultaneous system of equation is ill-conditioned system of. So, the system of equation is said to be ill-conditioned system of equation. I am giving you another example. This is your A, x and B vector, and if I solve this equation, I get a value of x equal to 2, y equal to 1. Similarly, if I change A to elements of A to 1.001 and so on, x vector, B same, B is not changed, then the solution of x becomes 2.00. Solving this equation, we get 2.003 and 0.997, which is very close to original solution. So, small changes in A leads to small changes in the solution vector x. Again, if I change the B vector to 4.001 and 7.001, keeping A intact, the solution of xy becomes 1.999 and 1.001. Again, it is a very close to your original solution 2 and 1. So, the system of equation given by this system of equation 1 is well conditioned system, as small changes in A or B leads to small changes in the solution vector A. Now, here A and B, Ax equal to B, this equation is a very simple equation with two variable or two equations only. So, it is easier for us to see the conditioning of the system using this method. But when it becomes a very large set of equation, then it will be very difficult for us to find the conditioning of the system using this method. And for that, we must use the matrix norm to find the conditioning of the equation. So, in the next class we will be seeing finding the conditioning of the system using matrix norm. Thank you.